Demonstration of the TrueView 360 Fluid Intelligence Platform. My name is Ken Caldwell. I'm product manager for the Minilab series at Spectro Scientific, and I'm pleased to make this introduction to you. Many of you in this webinar have participated in prior events and communications about the TrueView software platform. So I'm going to spend the majority of the time today going over the actual operation of the software and not so much the framework or the detailed performance of the Minilab as an instrument itself. That said, a little bit of context for the following slides will be helpful. So I have presented, after a short introduction of a few slides, then the outline of what we'll be covering on the actual software demonstration. And of course, we'll be fielding questions and answers. At the bottom of your GoToMeeting, the webinar box, there's a option to expand a section called chat, C-H-A-T, chat. If you click on that, you'll be able to enter questions by text, and at the end of the presentation and demonstration, we'll respond to those individual questions one-on-one. So I budgeted roughly 15 minutes there. Sometimes it's 6 minutes, sometimes it's 20 minutes. I'll be respectful of the time and make a sincere effort to finish promptly before 1 hour. So just a real quick snapshot of what the Minilab series is. The Minilab series is an on-site oil analysis system which delivers lab quality analytical results in your industrial site, in your plant, using this instrumentation. It provides simplified workflow for the non-expert user. There's no expectation that the operator is a chemist or an engineer. We don't require that for operation. And we provide tri-vector reports which give you not just the analytical results, but immediately actionable information like, here's a recommended action to take place for this particular alarm condition on this particular component. We'll circle back to that a little. These three bullets, they've been the mainstay of the Minilab series offer over the last 5 years. In the past year, we've migrated to a new software platform, the Spectro TrueView 360 Enterprise Fluid Intelligence Platform, and I'll talk about that now in more detail. So what is it? Well, it's a new approach in providing a predictive maintenance tool for reliabilities and PDMPs. Really, essentially, there's three aspects to it. One is the Minilab instrument, where the sample preparation is conducted and then the testing of the samples themselves. To do that, we use what we call a device console. It's TrueView 360 device console, which is for instrument interface, in other words, as well as data acquisition from the instruments, and then the display data. So the Minilab, if you will, is operated by the device console. And then finally, the item that we'll talk about primarily today is the TrueView 360 aspect of the software. Now, the TrueView 360 software is a software that's available as a service from Spectro. We provide a hosting service on the Spectro cloud, and that's our common offer and the common installation today. We can also install software on either just a local PC, where the analytical instruments, the Minilab, is connected, or you can install the software on your company server within your own firewall and have a fully networked capability with that. The TrueView software, regardless of where it resides, whether it's on the local PC, a company server, or in the Spectro cloud, is the same platform. It provides the databases, both the asset management databases and your reference oil database, a rules engine which provides diagnostic sets. We'll talk a little bit more about that before. And finally, allows for the trending of data on your assets and provides automated recommendations for diagnostics and maintenance actions. And there's also a performance dashboard which lets you look at a multi-level, the performance of your assets with respect to oil-related maintenance cost and oil consumption. High-level overview, not going to do much more detail on that. So now we're ready to transition to the software. This is just a screenshot to put it in context. So there's really four aspects. The upper right hand is the navigation bar, where you'll find things like login screens, help menus, settings, etc. An information section page where you can see that all these sections are collapsed, but there's sections on information, adaptive rules engines, the performance dashboard, and then the sample analysis process. And the left-hand side is the asset tree, where you build out your asset structure and identifying information such as types of components, limits, etc. And then finally, the toolbar, where based upon what level of the asset tree you're at, the actual tools within the toolbar vary. So that said, that's just a very succinct overview now. I will switch to the software in a moment, and we'll start navigating these individual scenes and go from creating the sample to processing the sample and looking at the final report after making whatever edits we want to before releasing it is what the balance will consist of. I did mention that the items displayed in the toolbar are a function of the level. They're context sensitive, in other words. And this is true both for the asset tree level, as shown here, where when you're at the before filter, which is your sampling point, that is, where are you taking the oil sample from, you have the option to edit, delete, schedule new samples, whether by calendar or created immediately a new sample for testing itself. I won't go over this asset tree now, but I'll come back to it in more detail. But in essence, from the bottom up, if you will, is the place you draw the sample from, shown by this drain here. In this case, it's set up to be done before a filter, which is on the pump. The component is the pump. The pump being a piece of machinery that has one and only one type of lubricating fluid in it. And then above that level, there's an asset. In this case, that asset is called a boiler feed pump. Now, you can imagine some assets only have one component in them. Others, such as a diesel haul truck, would have an engine, of course, but it would also have a hydraulic system and gearboxes, perhaps, that all would need to be monitored individually. So you go from sampling point, where the sample is drawn from the component, which is a pump, and a component is part of an asset. And a multiple of assets then make up a location. In this case, this location is called Generator Unit 3. I'll be running samples from Gen Unit 3 in just a moment. And locations are fairly arbitrary designation. You may have just one location at a site, or you may have building 1, building 2, building 3, for example, as 3 distinct units where your assets are, and you want to group them together because perhaps there's different people responsible for them, or you want to make it easier to set up scheduling of sample routes, that sort of thing. Finally, you get a multiple locations, completely flexible from that perspective. And then the actual instrumentation, where the Minilab instrumentation and other analytical instrumentation resides, is what we call a site. This site here is shown as Boston Power. So it's a Boston Power site. And of course, if I was a global power company like ABC, I would have a Boston Power, Chicago Power, a Tokyo Power, et cetera, et cetera. You could have multiple sites worldwide in an enterprise management solution such as this. I mentioned dashboard already. I'm going to just skip over this for now. So that's the quick overview of the overall structure. The piece of software that resides on the PC along with the instrumentation is what we call the device console. Essentially what it does, it allows you to, using a drop-down menu, you can see these 3 numbers here. These are sample IDs created in the TrueView software we just looked at. You go to this, you create all your sample lists for the day, you switch over to the instrument software and the TDC software here. You simply select an instrument, run it, upload results to the TrueView. I'll show all this in more detail, but basically we'll be downloading a sample that we've created by number. It will automatically generate a test suite based upon the type of component it is. Talk about that later. You press the run all, acquire your data, and then if everything looks reasonable, you hit the upload data, and that transfers the data from the sample measurement up to the TrueView 360, where the diagnostic sets are engaged and alarm limits are applied and automatic diagnostics and recommended actions generated. As part of the TDC, there's a feature you can turn off and on with a toggle, where we provide one of the key points on the Minilab are the simple tests and the fast results, and a simplified workflow for the non-expert user. And so to facilitate that, we've recorded videos that are embedded, and we have a sample wizard in there we can turn on, where it'll pop up the video and guide you through step-by-step each process step in terms of the preparation and running the sample. And then also it ties into the sample analysis process screen in the lower right-hand side, which we'll be looking at momentarily in the TrueView, where it stages you from the initial scheduling of a sample, the untested samples, that is, you created your sample list for testing of the day, for example, and then running through the process of diagnosing, releasing, and archiving. Part of the output of the report, a lot of information. I'm not going to dive really deep into it, but the report contains a trivector representation of the machinery health, which is a color-coded red, yellow, green based upon the alarm levels you set for specific parameters completely under your control. There's automated observations, which are tied to those alarm limits being triggered. Then, based upon the alarm limit, the parameter, and the component type, there's a unique set of diagnostics and recommended actions for that particular component type. At present, there's 23 default, component types, a variety of engines, flash gears, other gears, hydraulics. You can copy, you can edit, you can save your own. We have some really nice templates in here for applying limit sets, but we basically default to generic component type for reference. The report then lists current data as well as the last 4 samples, so for a total of 5 measurement points. And we provide, literally trend graphs for 39 individual parameters, trend graph of the parameters as a multi-parameter plot on trivector categories of the wear, chemistry, and contamination, and then the actual images from the LaserNet imaging system. This is an extremely comprehensive report. The nutshell, though, is we provide a slew of data. It's lab quality data. The important thing from an operator or a flow is really, at first look, you're looking at the report, the items within the solid blue lines here. Gives you the overall, alert, alarm, or normal, an indication here, green, yellow, red, which we'll see. Automatic observations, which are based on the parameter measurements and the limits. And then again, diagnostics and recommended actions from our default software, diagnostic sets, and other recommended actions that your operator can enter. So you get a report. So this is showing like the top half of the report. You get a big check mark. This report's all set. In other words, all results are below your alarm limits. So for the diagnostics, there are none. And the recommended actions is continue to, resample at your normal intervals. And so this is best case report. Your trivector is indicating no issues with contamination, chemistry, or wear. You get the overall thumbs up, so you just go. However, you could have a case where you triggered some alarm. In this case, acid number 10 is high, so we triggered an alarm there. Diagnostics and recommended actions are automatically populated. Again, these are unique to component type, and they are editable, so you can save them, change them, etc. And so we have that automated diagnostics. The operator could look at them and then continue on running samples or releasing a report. If they're been enabled to be the site user, and that's just a privilege that's set by the on-site lead, if you will, for the TrueView, they can also actually then edit those diagnostics and actions, as I mentioned, and use them elsewhere as well. And then finally, at the end of the process, we have an option. You can actually tag in what was found when the maintenance was finally done. In other words, by the time you get an oil report run, distributed, and then someone to read it and schedule related work actions, and then to actually have them completed, can take some weeks. So it's good to be able to make this feedback to the oil sample record in the TrueView platform. So just putting it all together, and you run your sample. This is top from left to right. You review what the diagnostics are generated by the software, decide whether you're going to just accept them and release, or if your site privileges, you can edit those before releasing the report as well. Distribute the report, schedule the work, log the results of those findings, and monitor then the overall performance at the asset plant and corporate level. Okay, I managed to shave 10 minutes off of the previous rendition of this, so I think we're in better shape now for the actual timing on the demonstration. So with that, I'm going to switch to the TrueView 360 software. So this is the TrueView 360 software platform. Again, this being again the asset tree. So I have an overall company name, ABC Global Power. My particular site here in Boston, Massachusetts is Boston Power. And I have a location set up as Gen Unit 3, Generator Unit 3, and boiler feed pump is my asset. And so I want to walk through the process of running a sample now. So again, in the context of, here's my toolbar, my asset tree with my component information, upper right is the navigation pane, and then again, these adaptive rule engines, the sample analysis process and data, for example, for sampling points. And we'll start. So let's look at the sample point process. Mentioned earlier, there's three ways of creating the sample. You can schedule it based upon a calendar, make it active. You want to do it once every month, and I could save that. Then on that date, a sample will automatically be generated and will populate back into the Schedule tab. It won't show up now because I just scheduled it. So I have another sample in here already, which is untested. Say I wanted to run a variety of samples. You just click that sample icon, hit save. All the information necessary to run a sample is already on the label. You could also save and print label if you opted to do that and print these out, which has the relevant asset information, oil life, et cetera, et cetera. So you just go through, create samples like that. There's another ability to run samples, which resides at the site level, where I can create a route. Oftentimes, it's convenient when you're doing samples, whether it's running pulling oil samples or running vibration routes. It's just to schedule a route by selecting individual components, and then whenever you want to run that route, you simply select the route and then hit schedule route. It will automatically generate all of the labels for that functionality. But let's just follow now through the sample analysis process. So I have two samples here now in the untested route. So as I go about through the course of my day, whether a sample showed up because I just added one like that, or whether one was scheduled by calendar, or if I ran a route, I now have 4 samples here in this sample list. And it's under the untested. And after I populate the samples, you can put 20, 40, 100 samples in here. You would then switch to actually then run the samples. So that's what we're going to do. We're going to move over to run the samples, upload that data back here, and then we'll come back and look at the pre-diagnose tab, which right now, there's quite a few samples in there. Let me just trash all those, and then we'll come back so we have a clean slate to work from. Okay, so now there's nothing in the pre-diagnose. So again, 4 samples. Let's switch now to the TDC. So I want to make the point again that Once you create your samples for the hour, the day, the week, whatever, you don't need to go back until you're finally done with all your samples to the TrueView platform itself. So for example, here are the samples, the 4 samples I created using this drop-down list. I just select one of them. You can see there's just a sample number here, which isn't useful, but the asset component and sampling point information is captured in the top header in the white lines. You can see this is generator unit 3, the boiler feed pump, and the sampling point before filter. So again, I have a demo mode on now, which I'll just show real quick, the tick box for demo mode. What this will allow me to do is to operate and fully demonstrate the software without being connected to actual instrumentation. In other words, in this mode, when I run through the sequence, the system will just generate some random data for the instrument measurements. So the other thing, which I'll not demonstrate right now unless there's time later, is the wizard enabled. That's what will make the video pop up as you go through the process of running the system. I'll come back to that and do that later, but now I just want to walk through the entire process as a operator would do it, who's familiar with the system, has been trained and has used the system. For our international audience, there's a variety of language choices available. We're working on others as well. And there's 2 pieces to the application, one being this TrueView 360 device console. And for this piece, the languages are fully fleshed out. The last one we're working on is Portuguese at the moment. Okay, so I have my sample here. I'm going to run all. You'll see this run measurements. This pushes the information to all the instruments. These instruments I'm showing here consists of these 4 pieces of instrumentation. This makes up what we call the Minilab 153. It's the product offer, the core product offer, I should say, for our industrial plants. So it's our industrial offer. And so since we have an asset tree that you tagged as a component type, it knows what kind of machinery it is. So for example, rotating machinery will have a certain set of test instrumentation, including, for example, particle analysis. Our standard engine test suite does not use particle analysis. Now, of course, you can control the individual operation, but for right now, just wanted to demonstrate that aspect of it. So let's, again, just grab one of these, 900 here, and I'm just going to run out. I'm going to point out the trivector here. There's nothing in it inside the colored circle. The colored circle means you're connected to the other software app, but we have some, measurement results here. These are the data from the demo mode. If it all looks reasonable, what you then do is go upload. Now, once I do that, after a second or two, this is going to populate with a trivector graph based upon whether we exceeded any alarm limits. So you can see that there is some there. Now, normally what an operator would do is that they would then just say, okay, I've uploaded my results. Let me just I got 20 samples here. Let me just keep testing my samples. When you go to run the measurements, you get both the individual text boxes, which can give you prompts or indicate necessary actions, and that's all the time. Or conversely, you could use, as I mentioned, the demo mode, which will show you. So again, I'm just running a couple of samples to populate data back up. I uploaded it. You can see again some color coding there. And I'll just run 4 more just so we have, if you will, that we have a trend data for a trend graph. And so finally, let me try the, I'm going to do the wizard enabled now. And so I'm going to try to walk through this process where I'm going to run measurements. Oops. All right, so now this wizard will guide you through the process of both the sample preparation as well as the measurement. I want to point out that the text here is localized. So of those 6 languages that I showed, when you select the language, that will display the appropriate text in the local language. So I'm just going to fast forward through a lot of these because I'm not interested in demonstrating the process. When we talk about agitating the sample, there's timers built in, how to pipette the elemental analysis and install that into the the Minilab itself and run it. So it's a very methodical step-by-step for all of the instrumentation in terms of how you would actually prepare the sample and run the device. Likewise for the total water measurement process, diluting samples if that's necessary for the particle count, degassing, and then again the sampling for the infrared, and flushing up in the final cleanup. So again, that can be turned on or turned off. Just turn that off in case we come back to it now. And it's as simple as that. And likewise, that demo mode can also just be selected off and on, can be used for internal training as well. So that being said, I have no more samples in my sample list. And so before I leave the TDC, which is my device console, with how I operate my Minilab, yes, I want to just look at again of the functionality there. And so you can select an asset in TrueView, come over, select that particular sample you've created against that asset, run the instrumentation, view the data, look at the wear images here, and then upload the data to TrueView. So that's the function of device console. It operates the Minilab and provides the interface to the TrueView software system. So where am I now? So let's just run those tests. So you can see that the items that were previously untested, those 4 samples that I just ran in the device console, have been moved now that I ran the sample and uploaded the data. They've been moved to this pre-diagnosed stage. So what this is showing you now is, again, the summary of the sample ID and the asset itself, the test date, the overall alarm code, and now you have a choice. You can go to just preview the report as it is now, before any edits, or you could go through and edit the diagnosis. So for the first case, let's just look at a preview of the report. And this would be as an operator would see it, because a regular operator would not have access to edit the diagnosis, but would be allowed to review and decide whether you could rerun that or not. So again, this is a sample report, identifying information up top in terms of the asset. This alarm came back with your ISO is high. The diagnostics could be a source of dirt, ingression, soft contaminants, etc. Depending upon the component type, it'll get more specific. Components that are part of an engine won't be talked about with a hydraulic system. So you'll have some very specific places of where to go. As I said, the operator would see these general factory supplied diagnostics and recommended actions, could make other additional recommendations before releasing the report, but that would be the extent of the changes. And you can see, again, all the parameters, the trivector indication on the left-hand side, which is indicating that in this contamination realm, this ISO code, which is an ISO contamination code, has triggered an alarm level itself. Again, I just have 2 points in this, but I'm just going to go through quickly. These are the individual parameter charts. We have a lot of information already out there on the parameters that the Minilabs can measure. It's frankly far more than most people would need. And then we group them by trivector category as well. You would have these multiple parameters, like silicone can be contributing to contamination, or your ISO codes, so could sodium, potassium, et cetera, et cetera. And then finally, you have the wear images, cutting wear greater than 20 microns, sliding, fatigue. So that's overall, that is the report for the trivector. Now, for example, I can edit the diagnosis. For example, I looked at this issue. My ISO is really high. Check data on filter used. Maybe missized. That's one comment I could make and save. I could also say that, well, there's only one recommendation, so I don't want to delete it. I do that on another one. And so you can just save and release that report. You can also just save the report with that comment and come back later to release it. But you can see what this is showing you is the current sample data and all the previous 4 samples and color-coded which ones exceeded your alarm values itself. So I'm just going to save and release. And let's just take another one. So that's moved over into the release section. All right, and this one had, so for example, let's say that while the overall code came back severe, I suspected there may have been an issue with maintenance in the past. So I'm going to select that as a verified to flag that to my team that, we need to check that out again, whether it's drawn another sample specifically or just maybe inspecting the area where the sample was drawn from to verify that. So I may decide that, for example, I don't need to verify these wear mechanisms using vibration analysis because it's already pretty clear to me that I have significant wear and I already have a good idea based upon my diagnostics where that wear could likely be coming from. But you could delete these individual recommendations. So I just edited that. Observations can't be edited. Why? They're simply telling you that you've exceeded an alarm value, and so you're thinking you're getting a lot of false highs or false lows. Well, readjust your alarm set. But basically, observations are just basically which parameters exceeded an alarm limit. And then again, you'll get recommended actions here. For example, for each individual parameter with a limit, it could trigger separate observations. So you just decide that, well, I'm not going to determine I'm going to clean my system yet because I'm going to go ahead and investigate my equipment urgently. And again, additional recommendations that will then show up in the sample report as well. All right, so I have a few reports released. Now, when I say reports are released, there's 2 functionalities. I automatically release those from the other categories. You can see now that I have a variety of released reports, not just today, but previous days as well. But you can also say, all right, I have a report, they're all looking good, so I'm either going to release it and notify or just release it. What's the difference? Well, release and notify will automatically send that particular report immediately to any of your colleagues that you've designated as an email receiver, which means when you click release and notify, they'll get an email for each individual report with a link to each individual report, a separate email. What most people prefer, since usually it's not quite that time critical for most oil samples, you can just release them, and then once a day there'll be a batch email that goes out, one email which has links to all the individual sample reports. The other aspect that I want to talk about in terms of email is, for example, you can set up what we call email receivers. So either at the asset information, you may have someone who's only interested in gearboxes, right? So you would only set them up to be an email receiver based upon the equipment that they're responsible for. Or you could set up, somebody responsible, set yourself up to receive all the emails and the links just to make, that sort of follow up. So it's a very flexible system. You can either assign all information to one person or all automatic reports individually. So that's one aspect of the email notification. The other thing you could do is set up, as I mentioned, the release notifies immediate. The release just goes into a batch daily, or you can, of course, delete. So we talked about, again, how to preview report, but then also we want to maybe edit the diagnosis like we did previously, because there's one final step. So I go through this process, I make my changes, I save and release. Then now that it's a release sample, let me find it in the release category here. And so there's one final step. So these report has been sent out to email notificators. They've received a report. Hopefully they've scheduled a maintenance item. The maintenance action has been done. Now there's some feedback. The maintenance team goes out and says, well, first thing, there's a leaky gasket which bled down the oil 4 liters. So not only did I have to change the gasket, I replaced the liter, but I saved probably a $5,500 rebuild on the gearbox because we managed to catch this before it had an actual hard failure. So you can make that notation, and that will increment the savings added to the dashboard level that we'll circle back to in a moment. You can add additional detail on the maintenance note screen here. And again, you can add freeform text or select tick boxes. Those, of course, will be accessible, so you can do some data analytics on your maintenance plan. And so you can go ahead and do those sorts of things. I'm just going to, I guess I'll leave those there now. And then finally, after you've had a lot of samples and been fully through the process, just to keep your release file, where you still go back into and do these maintenance notes, to keep that uncluttered, you can move then things to the archive list as well. So I can just, for example, move those to archive. So now they're off that list, they're on the archive list, and I have an empty release button. So I'm not expecting any maintenance follow-ups because I cleared out this queue already. So let me swing back now to the home page of the TrueView. And I'm going to talk about the dashboard. So it's case sensitive. In this case, we're looking at the site level. And what it's looking at is the overall, I don't have a lot of samples in here, the asset, the percentage of samples that were severe limits were exceeded or abnormal, high, low, or ones that you tagged that you wanted to verify by site, by location, and by individual component. You will have it tabulated so you hear that $3,500 total repair savings. I didn't log in an oil consumption per se. Let me get current here. So there's various information then that are available based upon, if you had a global company, you could then look at these performance metrics, which will highlight which samples have triggered, or provide links then to these samples that have triggered for further investigation, and give you a cumulative total repair saving and a total oil consumption, which is triggered automatically when you signify with the tick boxes that you've done those appropriate maintenance items. So then let me come back now to one of the core innovations. I mentioned that, Spectra Scientific has been providing Minilab for over 5 years, and it's only in this past year introduced this TrueView software with this adaptive roles engine. So at the sampling point level, for example, before filter, this is where edits can be made. I can customize. So what this is tell me all the parameters that I have assigned some type of alarm limit, whether it's an absolute number, percentage change, a real number deviation, etc. I can adjust those limits here. I can edit if I want the maintenance actions, which are fairly general because we're providing a very flexible tool. We're not presuming to know your equipment better than you do, right? So these are very generalized maintenance actions. But again, depending upon the type, in this case, this component type is a centrifugal pump, and I made this test suite up for that. but it's just centrifugal pump. You could go and change the values if you wanted to, or change the text of your actions. You can be very specific. You could say, well, if my ISO greater than 6 is triggered, I don't want to monitor. I want to haul out a filter card and schedule that PM. You could reference whatever standard work order you had for hooking up a filter card to that asset. And again, once you set these up, you can apply them either to the individual asset or all the assets together as a group, like have a new category of pump centrifugal. Likewise, and you can save it, or you can add a limit. In other words, give it a separate name, a new name that you can use elsewhere. Finally, and I'm starting to hurry just a little bit because I want to leave plenty of time for the questions. Under the component level is where the diagnostics for the various parameters that triggered can also be reviewed and edited. And again, we allow certain access so that your company can set up your TrueView so that most of your people are just operators, but you have one engineer or reliability person who's responsible for the limits and the diagnostics, et cetera, and only they have access to change this information.